So this morning we're going to make some motor mounts. It goes along with all the fab stuff that we do. We make all our own parts. So make just as much stuff as we possibly can. Today we're going to make motor mounts. So I got some 1/4-inch plate sitting in the bandsaw. We're going to cut those off into motor mount base plates. I already have the mount plates actually built and all slotted. We use a little different style. Our engines go up and down, where a lot of people, they have a mount that goes back and forth. The difference is I find the ones that go back and forth don't allow enough adjustment for your chains, so we like our engines to be able to move upward and downward. It seems to work much better. We've already cut the base plates off. Base plate right here. We've got them marked and drilled. The straight line that runs across is where we're going to put the upright plate that the engine bolts to. That straight line gets your plate all squared up for you so that you don't have your engine sitting on there crooked. We also use an angle finder, and we can determine what the degree is on that plate. I'm putting a little bit additional angle on this plate for a reason. On a dual engine cart with a box muffler, that muffler likes to blow right down on the rear tube, and if it blows down on the rear tube and it gets too hot, it ruins your powder coat. So I'm going to tip this upward just a little bit more than I normally would, try and get rid of that problem, or at least help it. So we're going to have this mount, we're going to build this mount with about a 9-degree angle on it, where normally we'd build a 5 or 7 degree. I've got this all set up, so I'm going to go ahead and tack it in place. Just a couple tacks, and then I'll check it for square, check it for angle, and then get ready to weld it. Angle's looking good. It's at 8 degrees. Put our magnets off. Looks pretty good. It might be a 32nd of an inch off at the most, which isn't going to hurt anything for the cart. We got that much adjustment in the holes for the mounting. And I'm going to tack it a little bit better, get ready to put the brace piece on. We have the brace already sitting in place here, ready to get ready to weld it in. I use a MIG welder on all of my welding. A lot of guys want to TIG their frames and such. That's fine if you have a TIG and you're good with a TIG. I use a MIG. Haven't found it to be a problem on chrome moly or on mild steel, either one. Depends on the wire you use, and also the want to have your welder set up on the correct bottle so that you don't have a problem especially when you weld chrome moly. Chrome moly was originally, aircraft tubing, meant to be welded with the gas torch. They still want you on aircraft to weld them with a gas torch. Most guys will MIG it or TIG it, but technology's changed, materials have changed. Today they find that a lot of chassis, race car chassis, everything, they're doing a lot of MIG welding on them and not having any problem with the cracking. So we'll get ready to weld this up here. have this base plate motor mount all welded up with the brace inside. Probably put one more brace, a short brace, in the middle. Not totally necessary, but I'll probably put one in there anyway. Alright, after a morning's work here, we got these two motor mounts all welded up, all ready to go to powder coat, all reinforced. These are pretty heavy duty. I don't expect them to ever break. If there's anything that makes me mad, is you go to an event and have something break. So all my stuff, I pretty much overbuild everything. One of the other things we also make, we make our own tie rods and front bumpers. We buy this aluminum, long aluminum tube. It's got about a 5/16 hole in it, so you can tap it to for a 3/8 heim joint. Make your own tie rods, whatever length you need them. Then you can also make this front bumper. We use steel tubing here, and then we put the aluminum tube through it, then bend it the way we need it for our front bumper. In vintage karting, it's basically a no-contact sport. We don't intend to get into anybody, but I do like to walk, so you never know when something's going to happen. I've been out through fences and been upside down and had about everything you can think of happen. And one thing I like is protect my feet. You just never know what's going to happen. Along with the other items we make, I also make all our own spindles. It's really not as hard as you think. What's really the best method if you're going to do it on your own is if you have a known good spindle, then make the jig off of that spindle and you can replicate that spindle. A couple things you might notice here. That's a bolt that you're looking at by the spindle barrel. What you want to do with that bolt though is you want to grind the edges off of it, grind all the coating off of it, and put a little contour in it, so when you drop it in there it looks a lot nicer when you weld it in there. Plus the weld doesn't like the plating on the bolt, so you've removed all of that. You might notice that little hole at the top of that spindle barrel, and what that's for is you got a choice there. Once that spindle's mounted up, you can take your oil can and lube that spindle at any time, or you can take a chainsaw grease gun and put it in that hole and grease that spindle. You don't really need a zerk in there. And I use a grade 5 bolt. I don't use a grade 8. Grade 8's too hard, it can snap. Grade 5 will bend before it breaks. I don't use a grade 2 bolt. It's a little soft, plus it's hard to get a grade 2 in a fine thread. So I use a 5/8 fine thread. Get it long enough so normally you're not out on the threads with your bearing. And then you cut the very end of it. And this jig is actually adjustable right here on these bolts. So I can make it work for other degrees. Once I get it set, I usually don't move it for what I use. I buy this long stock that comes and it's got a 1/2-inch hole in the center of it. I use a 5/8, so I have to open those up on a lathe. I cut them off and then I true the ends on a lathe also, so they're square. It takes quite a while to make up a good set of spindles and make your own barrels and everything, but you know, it's one way to do it. Spindle arms, you can buy the little Azusa spindle arms if you want to. I don't use them. I actually make my spindle arms. These are made out of 1 inch by 1 inch by 1/8 angle. You can see my arms are a lot longer than what the Azusa arm is. Also a little stronger. Don't ever have to worry about a bent arm or breaking one. And it also allows me to have the tie rods come out ahead of the front axle without going over top of the front axle. The longer the length the easier the cart steers. So my carts steer really easy. You could drive them with 2 fingers if you wanted to. All of our control rods for the throttle and brake, I make all those out of stainless steel. You can go to your metal shop. In this case, the shop I go to, I can buy 12 foot of, I guess it's actually a 10-foot piece of the stainless steel 1/4 inch rod for about $4.50. And then you have to thread the ends yourself. What you want to do on these ends is you want to take this end right here and you want to reduce the size of it for however the length is you're going to thread it. I just go up to my belt sander and sand the length of this all the way around as I spin it around in the sander, and reduce the size of it a little bit, then thread the ends of it. Then it threads pretty easy. Gotta have a nice sharp die. You will ruin a die every time you do about 10 or 12 ends. I'm actually using for cutting fluid. Thanks to Ted Johnson, I learned to use castor. Every time I empty a bottle of castor, the next day there's always a little bit left in the bottom, so I collect that and put it in my Tap Magic can and use it in place of Tap Magic. It actually works way better. Polish all our own aluminum on this old half-horse motor here with the buffing wheel, and you can use the white rouge to finish up your buffing. I use the black rouge because it cuts pretty fast. If you want it to cut even faster, spray your part with just a little bit of WD-40, or in this case there's some liquid wrench sitting right there to the side, and hang on to your part with those big old gloves, because it's going to get super hot on you, and it's going to be really hard to hang on to when that buffer wheel hits that greasy, oily surface. Most of the parts come out pretty nice when you get done. It's all in how much time you want to take. It does make a mess. Cut all my sheet metal in this table saw. All the sheet aluminum. I've cut up to 2-inch aluminum on this table saw. Be sure you wear a good face mask when you're doing it. Long sleeves. And do be careful. Make sure you go through straight, because if you don't have it straight, it is going to kick back and you are going to get hurt. There's always things we can't do, but I do as much of it as I can. In this case here, I've got this piece cut and bent to build an aluminum floor mount tank. It's the big tank I put in. It holds 2 gallons, goes in underneath the Azusa panel, up front Azusa panel. Have this piece bent here. Drops on here in place. And once I get this all fit together, I tape everything in place, then I take it up to a race car shop and have my friend Dan TIG weld this all together. I do put a area down here that traps the fuel so it doesn't run away from the outlets. And he furnishes the inlet for me. So there's a lot of ways you can come up with the tank you really need or the tank you really want. We also made a lot of aluminum seat back tanks basically the same way. A lot of the guys that are on the circuit have seen those tanks. They're pretty slick. Since I quit using 6061 aluminum, I haven't had any of the tanks crack or any of the welds break. 6061's a little bit hard. Doesn't like the vibration of the cart.